We are going to start training theory in this lesson, and we start from the beginning, which is adaptation. Adaptation, oh sorry, I have to introduce myself. So my name is Zsolt Radák. I am professor at the University of Physical Education, Budapest. My teaching topic is training theory, and I have a book on called Physiology of Physical Training, published by the company called Elsevier, Academic Press, last year, I think, or 2018. It is available at Amazon. So the title of the book is Physiology of Physical Training. I hope you will like it. You can have an e-book version as well. So, my research interest is molecular physiology, and mostly we are focusing on adaptation. Adaptation is naturally one of the most important processes, and Homo sapiens is really, really good at adaptation. So I will start with this slide, and the guy who developed this slide is a Hungarian guy called János Seje, but if you search the literature, you can find it Hans Seje, because Hans is the German version of János. So Hans Seje was a physician in the big Hungary a while ago, and besides being a medical doctor, he also showed interest in research. So in that time, in his research lab, everybody focused on finding new hormones. He was also in that project. What he did, he smashed the ovary of the rat, and then he injected it to another animal, another rat. And then one day after, when he opened the rat, he found out that the thymus, which is located here, got much, much smaller, and the adrenal got much bigger. It was very nice and important observation. So he repeated his study in this research, again injecting the ovary to another animal, and all of the cases, he found the same situation: smaller thymus and bigger adrenal. And then he knocked the door of his boss and he said, "Oh, boss, I found a new hormone. It is from the ovary, so if you inject it to another animal, you got smaller thymus and bigger adrenal." "Oh, that's very interesting," the boss said. "Let's everybody in the lab repeat the same experiment." And they did so. And Hans Seje János, when he summarized the results, he was surprised pretty much, because he was the less skillful guy in terms of science in the lab, and the difference was the biggest in his studies. But everybody got the same: smaller thymus, bigger adrenal. And then he thought of something, and his wife prepared gulyás soup, which is the most famous Hungarian soup, and he injected the soup to the rat. And they got the same result. The thymus got smaller, adrenal got bigger. And then he repeated it with palinka. You know palinka, which is the most famous Hungarian alcohol, spirit, made from fruits. And he got the same result. And then he injected something else. Doesn't matter what he injected, he got the same result: smaller thymus, bigger adrenal. And then he knocked again the door of his boss and said, "Boss, boss, boss, I got a problem. See my results. Doesn't matter what I inject, I got the same response." And the boss said, "Okay, forget it. This is completely junk. Try to find something else." But Sheye was a physician. And he remembered that when he saw guys in the hospital having completely different diseases, all of them looked like a sick man. Doesn't matter of the type of the disease. And then he set up the following theory. So if you get something here, stimulus, then the resistance of the body is decreasing against this stimuli, and then increasing, and then increase, and after a while you get an exhaustive phase, and the resistance is decreasing. And he called this as stress. Stress means stimuli which results this kind of adaptive response. This kind of adaptive response is called general adaptive response. General adaptive response, which means doesn't matter what is the stressor, the response is the same. So stress response is non-specific response. So this is very important. If you try to search the internet about adaptation, most of the cases you will get his work. Very, very interesting work and very nice. But I'm going to tell you this stress response, also it is true even today, it's not really applicable, not completely applicable at sport-specific adaptation. So let's talk about what kind of adaptation we have. We can separate adaptations to different kinds of adaptation. Let's see, acute adaptation. What does it mean? You know, in Budapest we got a river called Danube, and we got an island which is very nice called Margit Island. There's a very beautiful running track in the island, which is 5.3 kilometers or so. So let's take an example. If you go out and you run one lap, what is going to happen? If you start running, naturally your heart rate is going to increase, your breathing is going to increase. After a while, you are going to sweat, try to release heat, and then later on, probably you will find some discomfort in your joint, you will experience some kind of joint ache and muscle pain, and at the end, of course you cannot see, but for sure we can say that there is a decreased glycogen concentration in your muscle. This is a so-called acute adaptation. This is how your body is responding to this kind of adaptation. Or this kind of exercise, a single bout of exercise. But exercise training is a long-term effect, probably. So this is a chronic adaptation. Chronic adaptation means if you do exercise for a while, let's say 6 weeks, 8 weeks or so, after, let's see, you are running every day in the Margit Island, every day. What will happen? of course your heart rate is still going to increase. But after the 8 weeks, probably, from the same speed, your heart rate will be lower. This is how your body is adapting. From the same speed, you will have lower heart rate. This is also true probably to ventilation. We also decrease. What do you think what will happen with your sweating? Will you start sweat earlier or later? Yes, you are going to start the sweating earlier because you teach your body to get rid of the heat earlier. Later on we are going to talk about why this is so important. Okay, what will happen to your pain, joint pain and muscle pain? Yes, it will be not as pronounced at the first day after the first single bout of exercise. And the muscle glycogen concentration will be maybe higher after 8 weeks than after the first single bout of exercise. So we call this process as chronic adaptation, phenotype of adaptation. So if you do this exercise regularly, probably after a while we can see that your heart getting bigger and bigger, adapting to this regular and chronic exercise. So your left ventricular mass of the heart will be bigger. So for one contraction, your heart can pump out greater amount of blood. And the next step is so-called genotype of adaptation. What does it mean? It means that naturally we are not the same. We have differences. Can you name any short distance runner from Kenya or Ethiopia? Not really. They have very, very good long distance runners and middle distance runners as well. Can you name some long distance runners from Nigeria, Ivory Coast, Jamaica, Cuba? Not really. They are very good at short distance, and of course they are good at long jump, boxing, and all of the dynamic sports. And even African Americans, we can say, they are very good at dynamic events. So if you see the origin of African Americans, they are from the West Coast. So this really tells us that genetics, naturally, it is very, very important, and it really, in a certain degree, it can limit your performance at different kind of events. Maybe I have to say here, but maybe we are going to talk about this later on, that although I am not questioning the importance of genetics at sport, but I am questioning using genetical information for selection of athletes at different sports. Why do I say so? Because I think at the moment we don't have the tools by which we can really use genetics, especially in very complex sports like ball games, to select athletes. Not even track and field, because still, although there is an obvious difference between West and Eastern Africans, but we cannot really find the genes which are responsible for that. Later on we are going to talk a little bit about sport genetics, but anyway, to tell the truth, we don't have the tools at the moment by which we can select athletes. Naturally, not at fencing, not at football and many other sports, gymnastics. And the biggest part of the adaptation process is called evolution. We are so good at that, really, really good. There are different kinds of hypotheses how the evolution of Homo sapiens happened. I like one, and I'm going to explain it very shortly now, because by this I really can emphasize the importance of physical exercise in our daily life. So according to the suggestion, about 40,000–50,000 years ago, when we haven't got any fast food restaurants around, the biggest task of Homo sapiens was to get food. That time we haven't got any weapon to hunt, maybe just a stone. So according to this idea, because of the very limited maximal speed of the Homo sapiens, we followed the hunting tactic of desert dogs. What is that? We run after our prey animals, sometimes hours. Surprising? Yes, Homo sapiens have a really, really fantastic endurance capacity. And according to this idea, we run after the prey animal until the prey animal body temperature reached a certain degree, let's see 39, 40 degrees, when the animal stopped to avoid overheating. And then we could kill it with a stone or maybe by other methods as well. So according to this theory, endurance running was extremely important to the evolution of Homo sapiens. I know it's surprising, but if you see the longest distance what a Homo sapiens could cover in 24 hours, it is more than 260 kilometers. 24 hours. This is really, really incredible distance. Yeah. With cycling, more than 900 kilometers, and swimming about 100 kilometers. It is really, really fantastic result in 24 hours period. So the human endurance is really fantastic. The reason of that is the running economy of Homo sapiens is really great, much better than most of the animals. The heat releasing capacity is really fantastic. We can get rid of the heat which is produced by muscle contraction very efficiently, more efficiently than most of the animals. So according to this theory, actually high endurance capacity was extremely important of the evolution of Homo sapiens. And actually this fits pretty nicely with the Darwinian theory that the fittest can survive with a greater chance. So I do believe, I like this theory naturally very much, I do believe that although our genetics didn't change a lot in the last 40,000–50,000 years, that the development of our DNA based on very high physical activity, which is actually a problem these days because the very stable genetics, we have much less physical activity on a daily basis, and we have a good availability of food, and as a result we are facing a lot of problems which are coming from the lifestyle related diseases obesity, type 2 diabetes, and so on. So I do believe that we need much more physical activity than we practice these days, because our evolution based on higher level of physical activity. So this is how we separate adaptation, and let's see what is important to cause adaptive response. First of all, regularity. Regularity is extremely important. Regular loading, I would say. What does it mean? It means that at least 3 times a week. Yeah, 3 times a week could be very good and optimal to your mother and father, or grandmother or grandfather. 3 times a week. Because if you are sedentary, 3 times exercise per week would be very beneficial. On the other hand, if you are a top athlete, sometimes you have to do 3 training sessions in one day. So depending on the level of physical fitness, regularity is changing. So if you are sedentary, 3 times a week would be okay, but in case of high level of physical fitness, regularity must increase. Very, very important that the load that you are using here, this loading, must be big enough to cause fatigue. In my talk and in my concept, what I am trying to teach to you, fatigue is one of the key elements, and later on you will understand why it's so. And it is also clear that over a time, the same loading will not cause adaptive response. So you have to have gradually increasing load to cause adaptation. And lastly, I'm going to tell you that the adaptation, what we would like to achieve by exercise training, is specific. So this is a huge difference from the earlier slide that I showed you, in which Scheyer said stress is a non-specific adaptation. Doesn't matter what is the stressor, the response is the same. If this would be the similar situation here at adaptation, then let's see the training of the sprinter, gymnasts, marathon runner, soccer player, basketball player would be the same. Naturally, this is not the case. So the sport-specific adaptation is really unique. It is really a specific adaptation. So, as I told you, fatigue is important to cause adaptation, because if you go regularly to your fridge and take out your beer and go back and sit down and watching the movies, this kind of loading will be not good enough to cause adaptive response because fatigue will be not present. So the loading must be really big enough to disturb a kind of homeostasis of the athletes. So I would like to ask the question, if we agree that the load must be big enough to cause fatigue, and if we agree that the adaptation is specific, I think it's pretty clear that adaptation is specific, the next question is whether fatigue is specific or not. So the question is whether we have a specific fatigue or all kinds of fatigue are the same. This is very important question. So let's see what is happening in this slide. So you get here the adaptation curve based on the description of Matveyev, Russian guy. Let's separate the loading into three parts. I usually say the example of, let's say, running of Usain Bolt. So the first part, increasing the speed and keeping the speed, and he's smiling, no big effort, and then he used all of the motivation, and even in the last stage, even if his motivation, the speed is declining. So this is the fatigue curve. So this is the loading and fatigue together, because the loading must be big enough to cause fatigue. So the loading has two parts, three parts, depending on when we manage to keep the intensity of the exercise, and then when fatigue is really visible and the performance is decreasing. This is the case. And then from this part, when we finish the exercise, the compensation part, regeneration part is starting. So your body is going to compensate, do the regeneration at the resting period. And what is really happening, the compensation goes up a little bit. There is a kind of overshot here, which is called overcompensation, and then the situation is normalized. So if you see from this part, it seems that there is a kind of overcompensation here. This is extremely important, because if you do this loading regularly, loading, fatigue, recovery, loading, fatigue, recovery, loading, fatigue, recovery, loading, fatigue, recovery. And so if you do this regularly, from this part, because of the overcompensation, your performance is going to increase to this. So this is how we can improve the performance with regular loading and recovery. So if you just practice recovery, I can guarantee that you will not have increased performance. Just loading is going to kill you. So it is very important to mix loading and recovery. Loading and recovery. This is extremely important. So what is actually happening? The performance is decreasing during the loading period and increasing at the recovery period. Isn't it strange? So when you lay down on the couch after the training, your performance is going to get better because your body is recovering. So this is what you have to do. If the loading is not big enough, no fatigue, then you cannot expect good recovery. So there is a very small or no benefit of this kind of loading. This is underloading, which means that we cannot really hope to have better performance because the loading is not big enough to induce adaptive response. No fatigue there. There is another possibility when you have a huge loading, extreme loading and huge fatigue. Okay, the problem is because of the size of the massive loading, then you need a long recovery period. Then the problem is regularity. You cannot do this very regularly, so it means you cannot really hope to a good, optimal adaptive response. So one of the toughest job of the coach and athletes to find out the extent of the loading. If it is too low, no adaptive response. If it's too high, the regularity is a problem, and then no good adaptive response. So we have different kind of thresholds. And you know what? I'm going to tell you that these thresholds are individual thresholds. So what training would be A cannot work for the B. So that would be very tricky. And this is very exciting to find out the capability of the athletes to cope with the proper size of the fatigue, which results the most beneficial adaptive response. And the performance is not increasing day by day, not like this. If you are untrained, naturally at the beginning the performance is increasing in a greater degree. Let's see, if you are untrained, if you go to the gym and if you do bench press, let's see, you can, your personal best, one repetition maximum will be 50 kilo. Okay, you do that. One repetition, this is your best. So if you go there regularly, you can very easily go up to 40, 60, 70, 80 kilos at the beginning, very nicely. But if your best will be, let's say, 120 kilo, then it will be more and more and more difficult to further increase. So, and the increase is not like this, not a linear pattern. Sometimes you work hard and nothing happened. And then there is a jump. And then work hard, nothing happens, and then the jump again. So we have plateaus like this. So not a linear improvement at the beginning, maybe yes, but after that, not really. So what we would like to have a jump at the time of the main competition. So that will be very difficult. So when we are going to talk about training plan, periodization, and how to shape the performance, that will be very important to try to achieve the jump, the improvement of the performance at the best time, which could be the main competition of the year. So that will be pretty difficult. So again, what I would like to show by this slide is that the performance, the increases of the performance happens not with a linear fashion, but with a plateau fashion, up and down. Sometimes even can go down. Yes, sometimes you can go even down when you do exercise, then recovery, do exercise, then recovery, do exercise, recovery, do exercise, recovery, do exercise, recovery. And as you can see, the performance is not really increasing, so there is no overcompensation period in this situation. But what happens, despite of the lot of loading, a lot of fatigue, the performance is not improving, actually it is decreasing. So this phenomenon called overtraining or maladaptation, we are going to talk about that. And this is what could happen in many athletes at elite sport, and this is what we have to avoid. But actually, this is a serious problem in many athletes and many sports. So I try to emphasize the importance of fatigue. Actually, fatigue protects you. Extremely important. Maybe the first doping case was reported after the Olympic Games in Rome, 1960, when a cyclist reached the final and died. He used amphetamines. Amphetamines are stimulators. And what happened, this guy actually didn't feel the discomfort of fatigue, the pain of fatigue. So he didn't get the protection of the fatigue. So let's give you an example. When you drive a car, you have a scale which shows how much gasoline you have. This scale is extremely important because without the scale, you could run out gasoline, even in the highway, and you could be in the trouble naturally. What to do, how to go further. So this scale shows you what to do. Sometimes it also gives you a red light. Go to the gasoline station and refill your tank. But if you don't have this, in case of human, if you don't feel the discomfort of the fatigue, maybe you use all of your energy. And if you use amphetamines, which actually tricks your feelings, and then you cannot really understand what's going on, no normal feedback, not telling you how much you did, how much you changed your homeostatic balance. If you don't know this, this could be pretty dangerous. Actually, this is the reason why many painkillers are in the doping list, because pain is associated with fatigue. Look at this. So this is the fatigue curve. Depending on the stage, we have different kind of so-called discomfort. This is compensated phase. We can even smile when we run. But then, because of different kind of reasons, we have a pain sensation, and then we still continue doing exercise. We will suffer, and we can reach even the exhaustion phase. So this is how fatigue and pain are connected. And naturally, pain is also a protective mechanism. If you touch your iron, you feel at once the heat and the pain, and you remove your hand at once. But without pain, you would leave your hand there, and the damage would be very serious. So pain actually helps and protects you. This is the situation with fatigue. But I try to emphasize you that fatigue is extremely important at adaptive response. And hopefully I can convince you that fatigue is specific. Specific in many ways, because we have different kinds of fatigue. If you study my book, The Physiology of Physical Training, published by Academic Press, after a while you will feel, a cognitive fatigue. You are studying and then everything will be messed up. Maybe the same as training. At the beginning you are smiling and you can absorb everything, and then you use your motivation, but still the efficiency is dropping, and then the last, I don't know how many pages, you lose focusing, and then the observation of the information will be pretty weak. So the fatigue curve could be very similar, but the type of fatigue is different. So this is cognitive fatigue. You could have emotional fatigue. Oh my God, I am completely fed up with this training theory. Let's give me away. It's terrible. So this is emotional fatigue. Physically you are fit. Maybe your brain is also completely fit, but emotionally you are completely fed up. You could have even a sensor fatigue. Sensor fatigue if you spend the night in the disco next to the speaker and your ears would suffer a very significant impact, and everything will be okay, but the hearing, or just in case of judo, very important, the sensing, the touching will be impaired. And of course, the most important in our part, maybe the most important part, the physical fatigue, which means how your body is reacting to different kind of exercise. But in case of physical fatigue, we still have, I would say, specific fatigue, which means that fatigue is really dependent on the source. And the source of fatigue is dependent on the intensity of the exercise. Yes, on the intensity of the exercise. What is intensity? Intensity can be expressed as speed, velocity, load in the gym, okay, or frequency. And the duration can be expressed as, let's see, time, 2 times, 3 times, 10 times, can be set number, repetition number in the gym, can be distance, 20 kilometer, and so on. So the intensity of the loading and the duration of the loading is extremely important. And because the intensity of the loading affects the duration, naturally we cannot run marathon at the same maximal speed as we can run at 100 meters. So if you increase the duration, the intensity must be decreased. Or if you shorten the duration, you can increase the intensity. So intensity is the key element which naturally affects the duration. So what I am proposing here is that intensity of the exercise is one of the key elements, and the intensity affects the fatigue. And fatigue, the source of fatigue is extremely important, because if you know what is the reason of the fatigue, then you can really manipulate it, and maybe you can even delay it with legal tools. So this is one of the aim of the coach, to delay the fatigue at the given exercise, and if you do so, then the performance will be better. Sorry. So when we talk about fatigue, maybe we can separate fatigue into central fatigue and into peripheral fatigue. I am often asking my students which comes first, central fatigue or peripheral fatigue. Of course, there are different kind of approaches. One is that if you run on a treadmill, let's see, you are running on treadmill until exhaustion, until you are able to move, and then you push the button and okay, I am died. And then you still walk away. It means that your muscles are still able to contract. Muscle contraction is still happening, but you get a message from your brain to stop this exercise because you are jeopardizing your health. So this is a message which protects you. It's called fatigue. So if we see what is the reason of the fatigue, we can say that the reason of fatigue, the cause of fatigue, is dependent on the intensity of the exercise. Let's talk about clearly. Brain is a boss, naturally, the center. Central fatigue is brain fatigue. Brain needs a lot of energy. Actually, even at rest, brain consumes about 20% of your energy. Every fifth oxygen that you inhale has to go to the brain. Every fifth. So this is a really, really huge energy need. Brain cannot really store a lot of energy. Brain is dependent on blood glucose concentration. So if the blood glucose concentration is really going to go down, which we call hypoglycemia, where we are, if the brain glucose concentration goes down, then the brain going to send a message, okay, I don't have enough energy. Stop doing this. So this is what could happen. When is this kind of situation happening? Yes, you are right. It is happening when the intensity of the exercise is low and we have a long duration. Let's see. Do you watch tennis? Of course you do. If you see tennis players quite often eat banana during the match. Not when they are playing, between sets or games. They eat banana, which is very easily digestible, and then they want to avoid hypoglycemia. They want to avoid the drop of blood sugar concentration. That's why they are eating, to upgrade the blood sugar concentration, to feed the brain, and to avoid this kind of central fatigue. Very important, there are a number of studies showing that even if during the exercise, if it's possible, let's see in case of marathon or triathlon or ball games, when you are on the bench, you can really had some easily digestible sugars, sugar-containing food, or even drinks. This kind of sugar intake has a very beneficial effect on the performance. They can delay fatigue. So this is very important. If you know the reason, it's easy to handle it. Naturally, Usain Bolt will not stop at 50 meters to eat banana and then continue the running, because in his case, the fatigue, which is there, is due to from different reasons. Yes, even in 100 meters, when he completed the race, the time 9.58 seconds, actually not just Usain Bolt, all of the runners in that special competition reached their maximum speed at 80 meters. So their speed increased up to 80 meters, and then their speed started to decline. The decline means fatigue. Otherwise, their speed would increase until the end of the race, which not happened, suggesting that even in a very short period, 10 seconds, less than 10 seconds, fatigue is present. Naturally, from different reasons than hypoglycemia. Hypoglycemia is there when you got low intensity and long duration. I have to put this hyperthermia here because hyperthermia is naturally can be associated with hyperglycemia, which means again the intensity is low and the duration is high. So as a result of physical activity, your muscles are contracting. Muscle contraction results in production of heat. You have to get rid of the heat. You are evaporating and you are sweating during the competition. This is normal. However, your body temperature can just range in certain degrees. Actually, the normal body temperature is 36.56 degrees or so. And when you do exercise, your body temperature is gradually increasing. But then, if you get into a critical range, your body is getting a message. Oh, this is a dangerous zone. Please decrease the intensity or please stop doing exercise because of the increased body temperature. How to avoid this? One natural possibility is, of course, because hyperthermia and dehydration, which is not here unfortunately, you have to put the word dehydration here, so are associated. Because you are sweating, you are losing fluid. Then you have to uptake fluid. If you have a normal amount of fluid, then again you can sweat and get rid of the heat. Of course, it depends on so many situation dependent. The sweating is dependent on the temperature, humidity, and so on. So this is one of the reasons why the next Olympic Games, the Tokyo Olympic Games 2020, which will be 2021, but at the same time, end of July and the beginning of August will be a huge challenge for those who are competing outside, because the temperature will be very high and very humid. So a lot of people are going to suffer from hyperthermia, and that will be a huge challenge, and I would not expect very good results at, let's see, 10,000 meter running. To all of the endurance events with long duration will be a problem, or even tennis players have to cope with a very serious challenge at that time. So hyperthermia and also dehydration, as I mentioned to you, associated with fatigue, because your brain is sensing, always getting messages from different kind of organs, and then if the message is telling them, okay, you are changing the balance of the homeostasis, so this in certain situation you are getting into dangerous zone, so this message comes to the brain, and then as a result you will finish exercise. So then we have to talk about high intensity exercise and fatigue, central fatigue. So far I mentioned exercise with low intensity and long duration. But again, high intensity exercise case, fatigue is there, as I mentioned, Usain Bolt situation. That time the fatigue has many reasons. Again, one of the reasons could be the production of ammonia. Ammonia is produced in our body when two adenosine diphosphate get together and form adenosine 3-phosphate, and then we will have adenosine monophosphate. this process is catalyzed by adenosine adenyl kinase reaction. The AMP, adenosine monophosphate, cannot be regenerated. So it has to be degraded. And during this degradation, during this process, ammonia can be generated. And this ammonia gets into the circulation, and ammonia is a very powerful inducer of brain fatigue because it's neurotoxic. It has neurotoxic effects. Naturally, if you do high intensity exercise, you are producing lactic acid. Lactic acid going to decrease the pH levels, and all of the enzymes in our body has a so-called optimal pH. And if the optimal pH is if the pH is changing in the cells, in the brain, as an example, because lactic acid easily cross blood-brain barrier, so can get into the brain. It must go there because some cells in our brain use lactic acid as an energy source. So anyway, if the pH is decreasing, then different kind of enzyme activity can be decreased, and as a result, let's see, coordination of the movement can be changed as well. And we also have different kind of neurotransmitters such as acetylcholine, serotonin, and tryptophan. And this kind of neurotransmitters or protein, as a tryptophan, can also induce fatigue in the central nervous system. What is the cause of the fatigue in the peripheria? Peripheria is muscle, naturally, in this case. There are different reasons here as well. I picked up some. Just a minute. Good. One is increased concentration of intracellular calcium level. Calcium is very important for muscle contraction. When you have the stimulus coming down from the nerve, the motor neuron, then you have the depolarization of the sarcolemma, which is actually connected to sarcoplasmatic reticulum, which stores calcium. Then the calcium will be released from sarcoplasmatic reticulum, and then the calcium can go to the troponin, bind to troponin, troponin going to change the position and let the myosin heavy head bound to actin, and then if this cross bridge is happening, then myosin can pull actin together, and this sliding mechanism is producing the contraction. So in this process, as you see, calcium is extremely important because the troponin position will be moved by the calcium attachment to the troponin. But the problem is that the calcium has to get back to the sarcoplasmatic reticulum. And if you think about what is the most often happening injury in sprinters, probably you will see that the injury of hamstring, the biceps femoris here. The reason is the following. Naturally, every muscle has an antagonist muscle. So this is the flexor and this is an extensor. Of course, sometimes they help each other, but generally they are antagonists. Which means when the gastrocnemius here, when the quadriceps femoris here contracting, then the biceps femoris must be relaxing. Contracting, relaxing. Relaxing, contracting. So this is the play. So the situation is the following. Because of the very poor reuptake of the calcium to the sarcoplasmatic reticulum, many times the biceps femoris cannot be completely relaxed. But at the same time, the quadriceps is contracting, resulting in the injury or even tear of the biceps due to the decreased relaxation. So decreased relaxation of the skeletal muscle is one of the cause of the fatigue, especially when the intensity of the exercise is very high, such as sprinter case. Naturally, high intensity exercise results in lactic acid accumulation in the muscle, decreased pH level, and this actually would affect the power stroke of the cross bridge, the strength which is generated between actin and myosin will be impaired if the pH is low and the proton concentration is high in the skeletal muscle. Inorganic phosphate and adenosine diphosphate concentration also leads to fatigue, which happens with high intensity exercise in the muscle. On the other hand, exercise with a low intensity and long duration can deplete the energy level, in this case muscle glycogen level in the skeletal muscle, which easily results fatigue. And free radicals are also causative factors of the exercise. Nitric oxide and others such as superoxide, hydrogen peroxide or hydroxyl radicals are directly influencing the force production of the muscle. It is known actually that hydrogen peroxide level, H2O2 concentration, up to a certain level, increasing the force generation. You see, when the muscle is contracting a greater force, the hydrogen peroxide concentration increasing, which is very nice, and hydrogen peroxide concentration increasing the force generation, but after a certain level, the force generation going to drop. So there is a bell-shaped curve. After a certain concentration, hydrogen peroxide and NO as well increasing the force generation, and then after a certain concentration, if they are too much, they will inhibit or curb the force generation capacity of skeletal muscle. So as you can see, the reason of fatigue is completely different in different intensity. So this is very important. If you know what is the cause of the fatigue, then you can manipulate it. And it is also very important to understand that if you know what is the cause of the fatigue, maybe you know how long recovery you need. Naturally, if the fatigue is caused by metabolites, such as lactic acid, ammonia, as an example, then the recovery is very fast. If the fatigue is caused by the depletion of the energy source, such as muscle glycogen, then you need longer recovery. Is it important? Naturally, it is extremely important, because you know that what kind of exercise you use, you know how long recovery is necessary. Very, very important. When we talked about adaptation, please do remember, adaptive response happens at the recovery period. If you have too long recovery, it's a problem. If you have too short recovery, it's a problem. So understanding the physiology is very important because it helps you a lot to precisely design the appropriate training. It is extremely important to understand the fatigue and the endurability of the athletes, individual endurability of the athletes against the fatigue. This is also one of the key elements to proper creation of exercise training. So we will stop now for some minutes and we will be back later on. Thank you very much.